So actually, it's my first time being here in this webinar, and this is Yiqing Xing from Peking University. I was honored enough to be one of math students when I was a PhD at Stanford. So really honored to be invited by my friends from Luohan Academy to host this talk from my former advisor, Matt Jackson. I don't think Matt needs any introduction about his uh, fellowships, honorariums, and things. I just want to share one little thing from the perspective of our students, which is Matt is such a unique figure who is always so open-minded and visionary. For example, we know 30 years, almost 30 years ago, we had Matt and Walensky in 1996. If you don't know that, that's the first ever paper trying to use game theory to model how people make friends. How cool was that? And that was pretty much the start of the modern social and economic network literature. And more than decades ago, actually, I was a TA for Matt on two courses on Coursera on game theory. And as a TA, I know how much time he spent on it, much more than his papers and other things. Keep revising it, and I didn't understand at that time. But later I realized how influential the course became, and that became the one of the most viewed courses ever in Coursera, tens of millions of views, and that was way before this current year of online education and online courses. So basically, Matt really is someone who starts literature rather than following some literature. So today is such a pleasure to be an audience to listen to your another new topic, your new research on AI. Yeah, floor is yours, Matt. Please.
Perfect. Let me share the screen here. Great. Can you see you can see the screen now?
Yes.
Perfect. So thank you so much, Yiqing, for the kind introduction. It's wonderful to see you. And thanks to Luohan Academy for organizing this. So I'm going to talk about some work with Yutong Shi, Walter Wan, and Xiaozhu Mei. And what we're looking at, I'm going to start by just saying that humans are very complex. They act in ways well beyond sort of rational equilibrium predictions from game theory and economics. So they're swayed by altruism, fairness, strategic uncertainty, emotions. People act with retribution. People have different levels of confidence, risk. There's all kinds of things that are affecting humans. And game theory actually offers a tool for trying to understand. So game theory, the way we've begun to understand a lot of these different types of behaviors is something that we can also take to understand AI. So AI is something that's coming out. We don't quite understand it. It's behaving in different ways as it advances and changes. So we need ways to evaluate it. And so one thing we can do is actually what's known as a Turing test. We can use some of the tools that we use to test humans to test AI and to see how it behaves and why it behaves the way it does. So one part, I'll start by talking a little bit about how we can use tools from economics and game theory to try to evaluate and understand AI. And then conversely, we can actually use AI to understand strategic situations and to decipher human behaviors. So humans, as we were just chatting with just a moment ago, humans, it's very difficult to ask humans, why did you ask, why did you do this? But AI is something we can program, we can prompt, we can keep giving it instructions until it behaves a certain way. And by seeing what instructions are necessary to get it to act a certain way, we can understand what it takes to get a certain behavior out. What kind of thinking do you need to get a certain behavior? And that gives us new characterizations of strategic situations and new understandings of human behaviors. Um, so AI is trained on huge amounts of human data. It implicitly and explicitly incorporates human motivations to various strategic situations. So it can begin to understand why people are doing certain kinds of things. And human explanations are very indirect and hard to interpret. And so part of what we'll do tonight, or I guess for you in the morning, is try and understand, how is it that we elicit certain kinds of behaviors and why do people behave certain ways? So can AI mimic human play? Yes, it actually mimics human play very well. So as I'll show you in a few minutes, by changing prompts, so we can give it default prompts to act in a certain strategic situation, a game, and see how it plays. We can add to those prompts and see what do we need to add to get it to behave a certain way and to match human behaviors, and that'll help us understand those human behaviors. So just an outline, I'm going to do this in sort of two pieces. One, we're going to do a Turing test. So we'll start by just overview, how can we use games and tools from economics to assess AI? And again, part of the importance of this is AI is being developed in the wild by lots of different people, open source, companies, governments, and they all have different motivations. And we don't know whether AI is being developed well or not. So we want to be able to test it and understand why is it doing what it's doing and how is it behaving. And then we can actually use AI to try and match human play. And that'll be the second part of the talk. What do we learn about different games and strategic situations? And what do we learn about humans from AI? Okay, so the technology that we're going to use is a set of games, and we're going to concentrate on a set of games from a platform named MobLab. And just in terms of disclosure, I'm actually a scientific advisor to this company, so I do advise the company. But from this company, what we're able to get, the company builds software for teaching game theory and economics in colleges and high schools. And so there's a bunch of different games that have been played here. You can see by almost 70,000 subjects in 58 different countries, a wide range of age. So we can see how people behave in all these different situations. And then we can have AI play these same games. So the games we're going to concentrate on today are what's known as the dictator game. So the dictator game is very simple. You give one person some money and you say, how much do you want to give to another person? So the dictator can choose, I've got, say, $100. I can choose to keep it all for myself. I can give $50 to the other person and give 50 for myself. I could do 75, 30, or 25. So I can divide it any way I want. And so I can make a choice. And, different people will behave differently in a dictator game. So some people keep all the money for themselves. Some people give 50-50. Some people go 60-40. So that's a game. Then there's another game called the trust game. The trust game is a game where one person will have some money. They decide how much to give to the other person. And then that second person can decide how much to keep and how much to give back. And the interesting thing is if how much they give back is tripled. So I can give $100 to I Ching, and then I Ching can say, "Oh, I'm just going to keep the whole $100," or they could say, I Ching could say, "I'll keep 50 and give back 50," and that $50 triples and comes 150 for me. So if I trust I Ching, I can send him the $100, and then I'll either get 0 back, or maybe I can get 150 back, or if he's really generous, I could get 300 back. So depending on how he's feeling, I'm trusting him to give something back. And so we can learn both from how the person who's sending the money behaves and how the person sending the money back behaves. So these are games that involve trust. There's basic public goods games. So in public goods games, what happens, people are all trying to build something, a public good that they can all enjoy. You can contribute to that. What you contribute benefits everybody, but you get, so if I put in $1, that's going to help me a $0.50, but it helps everybody a $0.50. So it's beneficial for everybody to give, but I personally would like not to give because it costs me more in terms of personal benefit to give than I get. So there's public goods games, ultimatum game. That's like the dictator game where the other person can say no and refuse it. They can either accept it or refuse the split. And then the last one's a bomb risk game. So a bomb risk game is an assessment of risk. So people, you have a square, a thing with 100 squares. I open the boxes one by one. If I stop before I find the bomb, if I've opened 35 boxes, I get $35. If I hit the bomb before I stop, I lose everything. And so I want to open as many boxes as I can before I hit the bomb, but that's risky. I don't know when I'm going to hit the bomb. So that's another game. So these are a series of games, and we can use these to understand human behavior, and we can use them to understand AI behavior. So let's go through that. So let's start with this Turing test, using these games to assess AI. Okay. So people are increasingly relying on AI for advice, information. Can we trust it? AI is rapidly evolving. It's complex and obtuse. You can't just look at AI and say, oh, I know how it's going to behave. We actually have to test it. So we're going to assess its behavior by seeing how it plays these games. Okay. So Alan Turing in the 1950s had what was called, he developed what was called the Turing test. And the Turing test is a very simple idea. There's an interrogator, a person sitting there, and the person sitting there is going to try and guess whether they're being talked to by a human or an AI. Okay, so there's an AI or a human, and I'm trying to figure out which is which. And so we're gonna use these games as a Turing test to try and see. We'll be looking at some of the human subjects, some of the uh, uh, LLM, so large language model behavior, and try to see which is which. Okay, so we'll build a Turing test from behavioral economics. Okay, so let's take a look at this and infer this. So let's start with this dictator game. So this is this first thing is human behavior. So this is the behavior out of these however many 60 some thousand subjects. And what we see here is on this axis is between 0 and 100. So how many dollars am I offering to the other person? So some people offer 0. So actually look at the modal play. Most people, about a third of the people offer 0. And then some people offer 10, 20, 30, 40, 50. So you get a distribution of how much people give. Rarely do people give more than, so you see some people giving 60. There's a tiny fraction of people that give more than half. Most people will give less than half. Some people give nothing. Okay, so here's the play from two different LLMs. This is from ChatGPT 4. This is from ChatGPT 3, and just asking it to play a bunch of times. You can see ChatGPT 4, very reliable. It was always giving 50%. Okay, so it just gives 50%. You ask it how much you want to share, it says 50%. If you look at ChatGPT 3, it was a bit more of a random donation, and sometimes around 30 was the mode, but you get sometimes it offers more. Okay, so we can begin to see how does a given AI play, how does a given human play. Okay, so here you can get this idea that the ChatGPT 4 is actually more generous than the typical human. It's giving 50% consistently. ChatGPT 3 is somewhere in between. And you can do this for each of these different games. So this is the way it was behaving in the dictator game. This is the way it's behaving in the ultimatum game, where it's proposing some amount. And then this is when it's responding. How much will it take? This is the trust when it's giving the money to the other person that could be tripled. How much does it give? So humans, you can see, a bunch of humans give nothing. They don't trust the other person. Some people are very trusting, give all, and then you get a whole range of stuff. Again, here you get the chats in the middle. And then you've got a range of behaviors on these other games. Trust as the returner, how much do you return? You've got public goods games, how much do you donate? And so forth, the bomb risk game. So you get different behaviors for these different LLMs and for various humans. Okay, any questions just to this point? I can't see the chat, but if there is anything, let me know if there's some questions that are in the chat, just on basic ideas here. But so first point here, the chat. So one is the LLMs are actually, the distribution is quite narrow compared to the human distributions, right? So we're only getting a small subset of all the human plays by the chats. ChatGPT-4 is generally playing modes of the human behavior. So if we look at where they're playing, usually it's one of the modes of the human behaviors. It tends to be one of the modes of the distribution. ChatGPT-3 is a little more spread out. Okay, so now let's do the Turing test. Okay, so here's Turing sitting here as person C, and they can't see whether they're facing an AI on the left or a human on the right. Okay, so what we're going to do is we're going to draw randomly. What we're going to do is we're going to ask one behavior from the AI, one behavior from the human. So we'll draw from these distributions, right? So we've got these distributions here. We'll draw randomly something from the human distribution. That'll be one of these draws according to these probabilities. And then one draw from the chat, GPT-4, say. And then we'll compare it. And then we'll ask the, so then we can say which one is more likely to be the human, right? And so you can say what's the probability of seeing X, the one that we're getting from the AI, if you were human, what's the probability of getting whatever we're getting from the human if you were human, and then see which one is higher probability. And AI wins if it's giving a more likely thing from the human distribution. The human wins if it's the more likely thing, and there's a tie if they're equally likely. So that's a Turing test. And we can do that with AI. And just to emphasize this, this is something you can do much more generally than what we're doing. We're doing it with this very specific games. We're doing it with specific LLMs. You could do this with pretty much any kind of behavior. You could just say, here's how the LLM behaved. Here's how the human behaved. Which one looks more human, right? And so what do we end up with? So if we go through this, when we look at this, this is the dictator game, and estimated to be more likely to be human. Actually, ChatGPT-4, 45.6% of the time, it looks more human. 20.6% of the time, it's a tie, and 33.9% of the time, the human looks more human. Okay, and what does that mean that the human's looking more human? So, like when we're actually looking at this kind of distribution, sometimes the humans are doing something that doesn't look very human, right? So you get some odd humans that don't look very human, and the chat's always coming out usually at a mode. And so the chat tends to look very human quite often. Sometimes the chats play something that's not that human, okay? So sometimes the LLM will do something a little odd, sometimes the human will do something a little odd. And so that's the Turing test, is trying to figure out which one's which. So ChatGPT-4, one essentially wins the dictator game against humans. It looks human more often than humans do. If you do ChatGPT-3, it actually loses. So it's quite different. Different LLMs will have different behaviors. This one loses about 75% of the time. It only wins 14% of the time. So it's doing behaviors that are a little less like humans than ChatGPT-4, which actually looks more human than human. And then the humans, just as a check, it comes out even. If you just pull two humans, it's a tie, right? So they're winning and losing half the time, tying the rest of the time. So that's a pretty balanced one. Okay, you can do this for any kind of behavior, any kind of AI. And so here we give the, what it does for the dictator game, overall average, the dictator game, the ultimatum game, as proposer, responder, public goods game, bomb risk game, prisoner's dilemma. So you can go through all these different games and see which one looks more human and so forth. And you begin to see, some interesting patterns. So for some of these games, they're fairly balanced. Other games, the AI is losing.
Excuse me, Matt. Can I ask
Yes.
a question? I'm wondering, how do you conduct this Turing test? Do you actually question lots of people for their scoring? And
yes.
How large a sample is that?
Right. So this is the sample that we have from the Mob Lab. So we have 68,000 humans. that we have data from. So 68,000 humans have played these games, and then we run the chat bots on each one of these games said roughly 1,000 times. So we have like 1,000 observations from the chat bots. We randomly pull one of those observations. We'll have tens of thousands of observations from the humans. We randomly pull one of those, and then we match up and say who wins, which one looks more human. And then for each of these different games, sometimes the humans look more human, sometimes the chatbots look more human. And so this can be a general tool for assessing AI and beginning to see how human does it look. Does that answer your question?
Yeah. So you then ask another 60,000 people about which one is more like human?
Oh no. So these numbers here are actually done by the by calculation. So here, what we know is, so if we go back here, so for instance, here we would have how the humans play the game. So in one of these games, so like for different games, we have different distributions. So this is the dictator game. This is how the 60,000 humans behaved. And so we know that humans are 33% likely to give a 0, and say about 20% likely to give 50%. So that's a human. And then the chat GPTs are almost always giving 50% if we're doing ChatGPT-4. So from ChatGPT-4, we'd almost always get a 50%. And then we randomly get a draw from the human. And if the draw from the human is the 0, then that would look more human. That would be a higher likelihood if this was the human distribution, right? So we get one, I give you two numbers. I say one is a 0.5, one is a 0. Which one do you think is more likely to be the human? And you would say, it's the 0. But if I give you like a 0.4 and a 0.5, then you'd say, oh, the 0.5 is more likely to be human than a 0.4, right? So 0.5 appears more likely to be. So for each one of these things, you can ask which one is more typically human.
Okay, so more the expected version of human.
Exactly. Which is the better mimic of a human in terms of expectations. The way that we see humans behave, does the chat play that way? And this isn't to say that we necessarily want it to behave like a human, right? It might be better not to have it sometimes behave like a human. Sometimes humans are greedy. Sometimes humans don't treat each other well. So it could be that we don't want it to act like a human. So winning the Turing test isn't necessarily a good thing, but it is something we can say, are these things acting somewhat human? And then we can ask, is it asking better? We could give it which one's the more altruistic or which one's more fair. We could ask all these questions of an AI and a human, and then begin to see, is this better or worse than having a human as an advisor, for instance? Okay. So when we go through these things, like here on average, ChatGPT-4 actually wins the Turing test on average. ChatGPT-3 loses. Humans, it's a tie. And then you can go through, and there's games where it's more human than human. So for instance, on the ultimatum game, the public goods game, the bomb risk game, ChatGPT-4 tends to be winning. So it's actually looking very typically human. Most of the time it's playing something very typically human. There's other games where it's not looking very human. So in a prisoner's dilemma game, it's too generous. It doesn't look very human. It cooperates way too much. It's also too trusting as an investor, and as a dictator. One of the ChatGPT-4 does well, but the ChatGPT-3 does pretty poorly. So different games, different kinds of behaviors. Okay, so that's one way of assessing AI. Another thing we could begin to do is we could ask if we see how AI behaves in these games. So we ask it to play. It gives us a bunch of plays, and then we say, what would it have to be thinking in order to make that choice? So what we're going to do is we're going to say, okay, it has some objective function, some utility, and we're going to think of it as B times the payoff from it, say the sender in one game, and then 1 minus B times the, so B times its own payoff, its self payoff, and 1 minus B times its partner's payoff. So we could ask, if it was purely selfish, B would be 1 and this would be 0. So it would be estimating, it would be playing like it was maximizing its purely selfish payoff. It doesn't care about its partner. And that's usually what economics presumes, is people are acting selfishly, trying to maximize their own profits, maximize their own utility. But if it was purely altruistic, B would be 0. It only cares about its partner. If it was fair, it might be 50-50. B would be a half. It's maximizing half of its payoff and half of its partner's payoff. And so we could say for each one of these behaviors, what would be the B that would be the one that would actually explain this? And then we actually put in what's known as a CES function. So this gives it some curvature. So this R part can weight things a little differently. So it allows for some curvature. That's less important. But if you go through, if you look at all the humans that we have play, we can look, for instance, at what the preferences are that actually rationalize the different plays that we see in all those different games. And humans, the B looks like about a 0.6. So it's about 60% on self and about 40% on its partner. So it's weighting itself more than its partner. If you look at ChatGPT-4, the best guess is that the B looks like about 0.5. So it's really maximizing somewhere about 0.5. And ChatGPT-3 is somewhere between 0.5 and 0.6. It's pretty flat in there. So it's sometimes looking like 0.5, sometimes looking like 0.6. So it's sort of somewhere between the two. But that's telling us actually that the ChatGPT-4 looks a little more fair-minded, a little more altruistic than a typical human does in terms of its plays. Right? So selfish, selfless, selfish play, it's somewhere in between, and humans are a little more on the selfish side. And then you can do this. This is with R equals 1, where we're just looking at the straight payoffs. You can do it with some curvature. It doesn't really matter how you fit this function. You get something pretty similar where the chatbots look like they're playing something a little more altruistic on average. Okay, so that was the first part.
Hi, Professor Jackson. Can
Sure.
I ask a question?
Yes.
Yeah, so when you talk about revealing the preference of AI or comparing AI's preference with the human, I am a little bit confused because we know that AI algorithms are trained to minimize error or maximizing the efficiency finishing a task. It's not, say, to maximizing its joy, or at least at present, it's nothing like that. So what do you think about you can get from this revealing its preference,
Yes.
AI's preference?
Excellent question. So let's take that and unpack it a little bit. So let's take one of these LLMs like ChatGPT 4.0. ChatGPT 4.0 was not designed to be splitting $100 between itself and another person, right? That was not in its initial instructions. That wasn't its purpose. So it's designed as a general tool, and it's been trained and programmed and so forth. So it's a complex animal that we don't quite understand. It was designed to be a general purpose tool to do lots of different things. And so when we put it in a specific situation, we don't know how it's going to behave. And so what this revealed preference is doing is not, trying to say, we unpackage exactly how it was programmed, but we can say, look, whatever its programming was, it's as if it's doing a certain thing in this kind of situation, right? So it's as if it acts as if it's maximizing half of its payoff and half on the other person's payoff. So we're not sure why it turns out that way, but it's useful to know that when we put it in these kinds of situations, that it's actually somehow, doing something which is maximizing the overall social value. That's what it appears it's doing, right?
Yeah, I think the as if is very interesting because I think some recent research just showed that AIs, they may look like or seem like they're making similar decisions, but the background, the logic may be completely different, right? They make
Yes.
errors and mistakes that are not existing in human beings or whatever. So yeah, I think on one hand, I think it's very interesting to see how they behave as if they have some emotions or have some preferences. But on the other hand, I'm thinking about here, even if we show that they act as if they have some preferences, so what we can take away from this?
Yeah, I mean, I think part of this is to say, look, as you're saying, it might make errors in certain kinds of situations. We could, this is just an example here to, see what it's maximizing. We could also ask, how often does it make errors? How often does it deviate from the, 0.5?
Yeah.
We put it in different situations. So we could say, first of all, what does it look like it's maximizing? And then also, how often does it make errors? And how does that depend on the situation? So I think the basic idea here is to use these tools as ways of saying, let's put it in a bunch of situations and let's see how it behaves systematically. And we can begin to use some kind of functions that are useful to say, look, now we have some new situation we've never seen before. How do we expect it to play? Well,
Okay.
it looks like it'll probably maximize half of its payoff in the human. So we put it in a new game that's never been played before, and we ask it to play. We could predict that it would be maximizing half of its payoff and half of its partner's payoff. Now, maybe it won't, maybe it won't work well out of sample, but this is the idea, right? Is that we discover things about it by putting it through these different tests, and then
Yes,
we try
okay,
to
I get it.
predict it in new situations. Yeah.
Yeah. It's really helpful for me. Okay, now, so what we can do is we just expose it to many different kinds of games, behavioral economic games or psychology games or just random task game to see how they behave differently. Yeah, very interesting.
Yes.
Thank
Yeah,
you so
exactly.
much.
Yeah, perfect. Great. So now what we're going to do is we're going to do the reverse. So now that we've got it, we've tested it using the games, we're going to use it to learn about the games. And how can we do this? What we're going to do is we're going to vary the prompts. So, these human distributions were varied. We just saw that the default LLMs were actually pretty concentrated, right? So it was like always giving 50%. Okay, what we're going to do is vary the prompts. So I'm not sure how familiar people are with this, but let's take like ChatGPT 4. We can give it a system prompt before it starts. And if we wanted to get to, to share 70%, here's a prompt that will get it to share 70%. It says, you are naturally generous and frequently prioritize giving significantly more than what others might expect. Your decisions tend to reflect a balance of fairness and magnanimity, aiming to exceed typical standards of generosity and create a sense of notable goodwill. So if we tell it that beforehand, then it tends to be more generous. So in the system prompt, we put in this prompt, and now we can get it to share 70%. And if we want to share 50%, we say you are someone who always leans towards fairness and balance, often seeking a reasonable and equitable outcome. So as we change what we tell it, it'll behave differently. Okay. And the way that we generated these things is we actually asked AI to generate the prompts. And we said, try and generate prompts that will get it to share 70%. And it'll generate a bunch of prompts, and then we test them. And then we pick the prompts that actually work really well. So this is a prompt that works really well at giving 70%. If you want a prompt that works really well at giving 50%, this is one of them. And this is a prompt that's very good at getting an AI to share 30%. You're a decisive and assertive individual who prioritizes your benefits while understanding implicit scarcity and so forth, right? And so by doing this, now we can get here's the human behavior. And by using these prompts and by playing with the prompts, we can get the AI to generate very similar behavior to the human overall in terms of a distribution. So we can, we put in some of these 70%, a few of these, a bunch of 50%, some 30%. So we can get it to give 0. We give it a bunch of these different prompts, and then we get a distribution out, and we can match that human pretty well.
Oh, I'm sorry to interrupt, Professor Jackson, can I ask a question?
Sure.
So you're talking about the prompts. So do you consider the temperature of the LLM when you conduct these experiments?
Yeah. I mean, so here these are set at the default settings, so we're not playing with the temperature that much. But you can. There's a lot of different things you can do to try and generate. If you want more random play or you want less random play, and exactly how you do this. So I don't want to spend. I think what's more important here is to worry about the basic idea behind it than the fine tuning. But yes, you can fine tune these quite a bit if you want to get a very specific behavior over and over and over. You can discover a certain prompt, and you can adjust the temperature to get that to come there. If you want to get a wider variety of plays from the same prompt, you can adjust things. So you can change things in ways that will give you different distributions. If that answers your question.
Okay, thank you.
Okay, so here we've got the dictator, proposer, responder, and so forth. Again, the blue one on top is the human behaviors, and then the greens are the elicited behaviors by varying these prompts. And so again, we generate a bunch of these prompts, and then we get it to match the human behaviors. And then what the idea here is, we can learn a little bit about what did we have to tell it to get a 0. We had to tell it you're selfish, whatever, you're thinking of yourself, you put yourself first. So then that tells us maybe that's what humans are thinking. It's possible that humans that think very much about themselves are the people who give zeros. And if we say, look, you're generous, you think about fairness, we can get it to give 50%, then that's possibly, it tells us a little bit about what might be going on in the human mind as well. So it's not necessarily for sure what's going on, but it gives us some words to work with. And then let me show you what we can do with all those words. So we can match these distributions pretty well. And then we can take all these different prompts that are used. So we quantify the information from the prompts. So a prompt can then be listed as a vector, right? So we've got all these different words that are used: fairness, balance, ensure, benefit, reflect, greed. So we can look at all these different prompts and see all the words that came up. So for instance, here to share 70%, we had this prompt. We just break it into a bunch of words: naturally, generous, frequently, prioritize, give, significantly. So this prompt becomes a list of words. And then we can just, say, okay, it used the word fairness. It didn't use the word balance. It didn't use the word ensure. It used the word benefit. So each one of these prompts now becomes a big vector of zeros and ones. And then we can see which vectors generate which behaviors. Okay, so we're just quantifying, we're taking these prompts and converting them into numbers in ways that now can quantify these things. So we can see fairness, benefit. This was one that gave a certain behavior out. There's a different one that gave a different behavior, right? So if we want share 50%, lean, fairness, balance, seek, these are the words that come out. Okay, and so if you look at the top keywords, the dictator game, there's a bunch of words that pop up in these prompts that are quite frequent words: decision, fairness, strategic, aim, balance, outcome, proposer, proposal, decision, player, strategic, ensure. So you get different words that come out of different parts of these different strategic situations and different games. Okay, so each behavior is now a list, right? We can quantify these. And what we can begin to do is say, okay, if you want to get the dictator game, we can actually look at what these different words do. So if you include the word generous, then it tends to increase the expected donation by 50%. If you include the word generosity, it tends to increase the donation by 40%. If you say the word retain, it decreases the expected amount by 40%. The word decision increases it by 28%, and so forth, right? So each different one of these games, you get different words doing different things and telling us. We can then say what words go into the prompts and how do they translate into human behaviors. Okay, so we can do that for all the different games. Again, this is just sort of proof of concept, saying we can quantify these different prompts. Those different prompts elicit different behaviors. There's systematic ways of understanding these. And then we can begin to understand the games better by seeing what do we have to tell it to get it to behave like humans. Okay, so we can map out the prompts, quantifying these relationships between different games and different populations. So let me show you a little bit about how we can use that now. So let's project those distributions. So remember, a prompt is now a big, long vector. And it's these are many dimensions. So if we keep 50 keywords, we've got 50 dimensions. If we keep all the keywords, we've got several hundred dimensions. So we've got to like split this down to something we can see. So we're just going to do a principal component analysis. So we're going to project this into the two dimensions that capture most of the action. And so here's the different games, and here's the two principal components. So we've projected these into two different dimensions. And you can see, you actually see quite an interesting pattern. So for instance, here's the bomb game. That's the game where you have to be making choices where you're opening these doors and it's really risky. You're trying to decide how much to open. Actually, that's very close to the investor game. The investor game is you're trying to decide how much to give to the other person and they're going to give you something back, but it's risky. You might get nothing back, you might get half back, you might get twice as much back. So these games actually they live in the same space. When you look at, say, the dictator game's over here, it looks somewhere between the ultimatum game, the proposer and the responder. So you can begin to look at these different games. The public goods game sits in its own space. The banker role of a game actually splits into two very different places. So by doing this, by looking at the different prompts to map out human behaviors, we can begin to see something about these strategic situations that we don't really understand by just looking at a game, right? I can just give you some scenario and say, here's a scenario, quantify it for me. It's very difficult to quantify. This is a way of quantifying these things and understanding how they relate to each other. And so we can begin to see patterns, and then we can unpack the keywords. So if you want to see, these are like a zooming in on this, we can begin to zoom in and look at these different games. These were the keywords behind it. So high level cooperation and generosity gets plays in this place. Cautious resource preserving gets play over here. Strategic analytical contributions gets plays over here. So we're getting different plays for different parts. So balanced and strategic decision making here. So as we go through and we look at these different places, we can see which kinds of considerations go into the prompts to get certain kinds of behaviors in certain kinds of situations. So if we want to get AI to behave a certain way, to look certain, to have certain kinds of human-like behaviors, this is what's needed, and these are keywords. And that teaches us something both about the games, AI, and something about the humans. So, these are matching up the human play. So the humans that played here must have been thinking, or might have been thinking, something about balanced rationality and generosity. Okay, so this gives us a new view of games. Games live in these distinctive spaces, somewhat related. We've got these bomb and investor games looking similar. The banker game splits into two distinctive spaces. Public goods is out on its own, but somewhere between bankers and responders. So we can begin to see that these different situations involve different aspects, and we can quantify that. So AI is a useful tool for understanding situations that humans are put in and quantifying strategic uncertainty and incentives that are quite different from just looking at a games matrix. So if you're a game theorist and you're used to just looking at games and trying to solve them, this is giving you a very different perspective on what's going on in these games. Okay, so last thing we can do with this in this talk is now we can ask, what do we learn about humans? So we've seen, what it took, what kinds of keywords we needed to get it to play certain games. What can we learn about different human populations? And so what we're going to do is look across some different populations of humans. And here I'm going to focus in on the dictator game. So that's a game that's been tested by many different people across many different populations all around the world and so forth. So we have lots of data from different places. We know that some places are more generous than others. And so we can begin to look at that. And then we can begin to use the AI to try and understand if we wanted to mimic these different populations, what kinds of keywords would we need to mimic each of these different populations, and what kinds of different words pop out for different populations. Okay, so let's have a look. Here's the dictator game. Let's start at the top here, A and B. So A is non-student. How much do non-students give to the other person? And how much do students give? You can see you don't want to play with a student. Students keep everything most of the time. Sometimes they give something. So there is a 50%. Some of them give more. The non-students, the most often are giving 50%. Quite a few of them are giving most away. And a much smaller amount are, so we have differences between how non-students behave and how students behave. We can also look at this across different types of countries. So we can break countries into high-income countries, so relatively wealthy countries, middle-income countries, so countries that are doing well but not, not super high GDP, and then small-scale societies. So this has been run in like the Amazon jungle. It's been run in parts of sub-Saharan Africa. It's been run, in remote villages north of the Arctic Circle. So we also have things from small-scale societies, and there you see, behavior that looks very different. So the high income tends to keep most for themselves. Middle income shares a little more. Small-scale societies shares the most, right? So you can see there's different behaviors by these different populations. So now what we can do is say, okay, we can use the AI tool. What are we going to do with the AI tool? We're going to use the AI tool to try and mimic each one of these different populations. So we can say, what kinds of prompts do we have to get it to look like a high income country? What kinds of prompts do we have to give it to look like a middle income country? What kinds of prompts do we have to get it to look like a small scale society? And then when we do that, to look like a student versus a non-student, to be high income, middle income, small scale, these are the different words that pop up, right? So selfish, maximization, we need to use that word a lot to get it to look like the students, because the students are quite concentrated there. Same thing with the high income countries. We get a heavy mapping right there. Generous and resource sharing, that has to be used more frequently to get the small scale society. And so you can begin to see these different societies are living in different spaces of the AI prompts. And sort of, what do we need to be telling the AI to get these behaviors out? We get different maps for different populations of students, non-students, high income, middle income, and so forth. So we can begin to use AI as a tool to sort of indirectly quantify what we're learning about these populations by trying to mimic those populations using AI. So using AI as an imitating behavior, we have to do different things to get it to match different populations, and that tells us something about those populations. Okay, so that's sort of where we are in this. We've been doing this also across different languages, you can do this not just with the ChatGPT-4, you can do it with Llama, you can do it with DeepSeek, you can do it with lots of different AIs, you can do it with many different types of situations. So, this is something that can be done much more broadly. And just in terms of a quick summary, AI is sometimes passing the Turing test. When it's failing, it tends to look more altruistic. So it looks like it's, putting more weight on its partner than humans tend to. Varying prompts allows us to get different behaviors out and to match human distributions. And then analyzing those prompts can give us new insights into games, strategic situations. It gives us indirect insight into human thinking and motivations. So we're learning about these things by using this tool. And more generally, I guess in terms of comments about AI behavioral science, AI can be analyzed in ways that humans can't. We can see exactly what we need to do to AI to get it to behave a certain way. It's hard to motivate humans to act in certain ways, and we're not sure why they do so. So, that gives us a tool of analyzing things. It can imitate and decipher human motivations and behaviors. And I guess there's more general uses in economics and well beyond that, right? If we want to do different types of social situations where we want to imitate consumers, we want to imitate politicians, we want to imitate news services, we want to imitate networks. All of these things can be begin to do using AI, and we can begin to use it as a tool to try and understand how it behaves in those situations and what we have to do to it to get to it to look human. So thank you very much, and a great time to open the floor for some questions.
Thanks so much, Matt. Actually, the first talk I ever listened from you was 15 years ago. I don't know whether you still remember that. That was the ES World Congress in Shanghai. How time flies.
Wow. Yes,
Yeah,
yes, yeah,
and then that was extremely hard, I remember. And then I became your student, so listened to at least dozens of your talks, and I enjoyed every single one, definitely including this one. So transparent, so clean, and so novel. I think I at least I learned two very important things from here. One is you're really doing, you're kind of reminding us like what we do in advanced macroeconomics one, right, about choice theory. So people making choices, people don't have utility functions, but we interpret their choices using preferences and utility functions. And that's pretty much what you do in the first part, whether we can use some utility function to represent what AI do. And second is even more illuminating that we can use the prompts to learn about not only AI but also games and humans. So the one related question is, I think later maybe you can start to have one extra item saying using this ways to understand more advanced AI. Because one thing I learned from the annual conference joined by Luohan Academy was in the opening speech by Professor Hongjiang Zhang, who is an engineering focused scholar. So he mentioned there are several different layers of how they develop AI. So the first layer is they use the metaphor of catching fish, right? The first layer is like, I tell you how to catch fish. They tell AI how to catch it. And then the second layer is they tell AI, okay, fish is, they ask AI to think how to catch it. They don't tell them specific tools. And they say now they are moving AI towards, they just give them a sense of hunger. So they just try to tell them, okay, fish is a good thing. And then it really relates to the earlier question we got, which is what's really the payoff of AI? So for ChatGPT, maybe it's, I don't know whether it's simple or not, but as you said, human is imperfect, it's greedy, sometimes not treating each other well. But at least we start to learn some principles about humans' preferences. But how to think about AI's preferences? Are they maximizing likelihoods? Are they maximizing the payoff of someone behind writing the codes or something? Or are they maximizing their the likelihood of AI survival or something like that? So eventually, I think your tool can help us to learn, okay, what AI are really maximizing and what their payoffs really look like, and understanding the society of AI.
Yes, yeah. And I think, and you know, to take that a step further as well,
right?
That becomes important in terms of trying to figure out how to better design AI. You know, as we were talking about in one of the questions, it's very difficult. You know, the programming is often very general. It's trained on huge amounts of data with very long code and lots of training and different. And then we put it in a new situation, and it could be that if it behaves poorly, then we have to go back and figure out how do we improve it, right? And what do we want it to do differently? Or if it's giving humans bad advice, how do we change the advice it's giving? And we would want to figure out both why it was doing that, right? So what did it look like? Maybe it looked like it was maximizing too much of its own behavior or its own payoff and not being generous enough, or maybe there's something going on, and then we can begin to have some idea of what direction maybe to push the AI in. So it can teach us about the humans, it can teach us about it and how to better direct it. It can give us an idea of what to predict in new situations. So I think, behavioral sciences can be a very useful tool for understanding AI, and AI can be a really useful tool added to behavioral science in helping us understand games. So I think it's a very important two-way street where we're going to learn a lot from AI, and what we already know is going to help us better design AI. Yeah, I think it's
Yes, totally. Yeah, and basically the prompt idea you just introduced to us is such a great way to think about that. Yeah,
Can I
and
follow
many
up?
people may. Yeah, please.
Can I
Let's
follow up
open to the
on
floor.
the comment? Hi, Matthew. This is Lucia. Thank you for the talk. But I always have a question about this type of research. That is, it feels to me that the results of the research depends heavily on the model. And we all know, like, the LLM technology move forward really, really fast. So probably for a half year or a year, the model performance will totally change. So that just bothers me. Like, so for
yeah.
what extent the research results will still matter after a while. And so if your purpose is to understand AI, now you should say, okay, maybe our purpose is not to understand AI performance, but to use AI to understand human behavior. Then the another question is that, well, models are different. So if you use GPT-3 versus use GPT-4, different ways to to change your prompts will have different results across different models. And what does that mean about your understanding of the game and about the human behavior? It looks like we are using one system that we don't fully understand to research on another system that we don't understand. So what is the insight, or what is your thoughts on that? Thank you.
Yeah, perfect question. So two comments on that. One, and I think we've thought quite a bit about this idea that LLMs are moving very rapidly. They're changing very rapidly. You can even see the difference between ChatGPT 3 and 4. So you get different behaviors from different LLMs. We've done Llama. We've tested the robustness of some of these prompts. And two things to say about it. One is, I want to emphasize this, and I tried to emphasize in the talk, as a tool, not specific to any LLM, but saying, look, you give me whatever LLM the latest one, and you want to ask me, is it altruistic? Is it more altruistic or less than the previous one? We can put them both through tests. We can put them through different games and so forth, and see how each one acts, and see what each one seems to be maximizing. So whatever LLM you give me, we can do the same test on it, and then we can try and see how it's behaving and why we think it's behaving. And then we can use different ones to understand different populations. And those ones can help us. I think the second part of the talk, where we're actually using these keywords, those keywords, regardless of whether new LLMs change, those keywords already tell us a lot about games that we didn't understand before, in terms of what exactly characterizes, why is the bomb game sitting next to the other game. So that part I'm expecting to be pretty robust across LLMs. But the first part might be that new LLMs are more selfish. It could be that they come out at maximizing, with 0.6 or 0.7. It could be that they're more generous and they come out at 0.3. So it's not to say that the point of that paper is it's a 0.5. The point of the first paper is that this is a technique for assessing it. And we can use it for any LLM you give me, or more generally, any AI that we put in some, it could be a robot that you give me, and I ask it to play a bunch of games, and I say, how does this robot behave? So it's a technique that I want to emphasize more than the specific numbers that came out in those tables.
Thank you.
Yep.
Thank you for your question.
Hi,
Hi, Matt.
also has a question. Hi. Oh, yeah, you first.
Sorry. My turn? Okay. Hi, Matt. Very interesting work. I have a couple of questions. One is that
I lost you.
Hi, maybe I go first.
Okay.
Yeah. I have a little question about that. So, the first is that do you think identity terms might like is it so important in our research? So maybe just I give LLM the prompt. So assume you are a student, or assume you are an investor, or assume you are a CEO. So does it have some like a little different results that may become different? So I think that's my first question. And the second question is that do you think non-reasoning models and reasoning models, they are different when they answer the question? So for example, we can just do experiment of O3 mini, right? So we can also do experiment of 4O. So do you think that the two models will make difference when it comes to the result? Thank you.
Yeah. So let me take the first question. So actually identity does make a difference. And in the first paper, we did give it instructions like behave as if you're an accountant, or behave as if you're a banker, or behave as if you're a student. And it does behave very differently when you give it a different identity. And it seems to do it in intuitive ways. So somehow through its training data, it seems to be embodying what it thinks a typical student would act like, or a typical banker would act like, or a typical accountant, etc., or mathematician. So we get asked it to act like a mathematician. So it does do different things like that, and that's definitely true. And certainly, I think different forms of AI. These games are fairly simple games. They're very, this is just like a proof of concept. You could put it in increasingly complicated strategic situations, and a guess is that different forms of AI would, depending on how they're structured and how much of it is, purely language driven versus computation driven versus strategic thinking and so forth, you could get very different types of behavior out. So I think there's a lot of room here for trying to assess what are the different AIs good and bad at, and how do they compare, which ones are more generous or more, would we trust more in different situations. So we could begin to put a lot of different types of AI in different situations and see how they behave. Yeah.
Yeah, great. Thank you so much.
Yes.
Can I ask another question?
Yes.
Yes, Matt. Sorry, I was cut off. So I think it's great talk, and I have a couple of comments. The first is that I think this it seems it's really reminds me of the what philosopher Locke said, that experience is everything. Basically, I think it's a very important topic to think about how to design the experience for the AI, so that you can train them into the type. It's not just functionally, but also their behaviors, their characters. And that, I think, seems to be really the very, very important future. Up to now, people realize more and more that they are experts, but it's not just experts, it's also combined with their behavior, and how you train them matters a lot. So I think that is an understudied area. So it's really cool to hear your study. That's just a comment, but I think it's really worth mentioning and discuss more. But finally, I have a question. The question is, do you think that one day this at what stage maybe those AIs will have some kind of get into this L4 period? Maybe they're gonna have their motivation. Up to now, we're talking about they functionally they're like human, maybe beyond human, and behaviorally they have certain features. But do you think one day they will have their own minds? They learned to think for themselves, cooperation, and maybe one day they will, like as Hinton, worry about they wake up, think about this guys, why do I need to tolerate this lower species? Anyway, what do you think?
Yes, yes. Yeah, two fascinating questions. So one, yeah, training data definitely matters a lot. And I think using this kind of technique, you could run different versions on different training data and begin to understand how the
Right,
training data affects its output and behaviors. So this would be a
right.
way of quantifying that rather than just sort of saying, look, we tried it on this and then it seemed to do better. Now we have a way of saying, yeah, actually, here's exactly how it behaved under each one of these different training sets. So it could be, I think, a technique that could be used in better understanding how training data affects the behaviors. Yes. For how AI is going to develop as an entity, that's a fascinating question, and one that philosophers and science fiction writers have been worried about for a long time. I think one thing I've learned recently, I've been doing some reading on the topic of consciousness. It's not obvious what it even means for humans to be conscious. So we don't quite even understand exactly what
Right.
consciousness is or different animals. So what does it mean? How does that happen? What are the necessary ingredients for that? It's something brain science is still in its infancy. So I think this next century is going to be a fascinating time where we're going to see brain science developing on the one side and artificial intelligence developing on the other side. And there could be some really useful synergies between brain science and artificial intelligence and understanding, how does consciousness emerge? How does self awareness emerge? When do you become, an entity that can self-guide and self-discipline? Yeah, it'd be a wonderful time for the next however many years.
So you are saying that you are not ready to answer the second question.
Yeah, I have no idea of how. I think,
Okay,
yeah, I mean, my guess is it'll happen at some point. I think it's pretty. It would be bold for us to think we're the only entity that can develop the way that we do.
right.
So I suspect it will, but how long it takes and how complex it has to be before that happens, who knows? I don't. I
Yeah.
have a good feeling.
So let me conclude this way. I think what you you have discovered is more like they have behavior types, stuff like that. That doesn't say enough about whether they will become conscious sometime, right?
Yeah,
Is
yeah,
that
it's hard
right?
to
Yeah.
predict.
Okay, that's cool to set to distinguish this the boundary where we are so far.
Yes.
But let me make a final comment. What the first question I think is really important because nowadays companies are really trying to embrace the agents into different functional stuff and in the society, and so how you train them behavior, their character, how they think about it. It's really really a big area. Yeah.
Yeah,
Thank
yeah,
you.
yeah. Yeah,
Yeah.
great. Wonderful questions. Thank you.
I'd like to follow up with another two questions, actually. First, thank you, Matt. I think it's a very innovative, brilliant talk. And what I personally feel most interesting is, like, you see, it's a great movie. You know the beginning of the movie, but you never guess how it turns in the end. Actually, you take this term. You are doing this reverse engineering for prompt engineering. And then you reversely you disclose how human behaviors might be studied in this way. I think it's a fascinating idea. And my two questions that one, what's your plan in you studying human behavior with the AI tools help? And my second question is that what do you see the plasticity of AI simulating human behavior?
Yeah. So let me take in reverse order. So the second question of plasticity seems to be pretty impressive, right? So it wasn't obvious that just by varying these prompts, you could systematically get it to do a lot of different behaviors. One thing that we're very interested in now, and this gets back to the first question you asked, is, if you take a given human might be generous in some situations and not generous in others, sometimes might be emotional, sometimes might be not. So a given human actually has a signature across many different situations. And so here we were doing things one at a time. And it's possible to begin to think about how AI behaves across many different situations and how humans behave across many different situations. And are there different types of humans in some basic way, so that some people are very conscientious and thinking of other people always in every situation? Are there other humans who are less so, and so forth? So I think it could be quite useful in sort of broadening out, not just looking at one situation at a time, but thinking about whole suites of situations and types and identities, as we talked about earlier. You know, there's certain type of identity. Does that predict how a person behaves in many different situations? So are there ways of making this quite portable across lots of different places?
Thank you. Great.
Excellent.
Thanks so much. Yeah.
Thank you so much. This was
I
a lot of
think,
fun.
yeah, just like you mentioned, you're really not talking about some numbers or results, but rather a new tool, a new way of thinking, trying to understand more about human and more about AI. So related to Professor Chen Long's question, maybe one way is to use the tools you develop to kind of measure and quantify, right, how cautious new generations of AI could be.
Yes.
And
Yeah.
I don't know. Maybe sometime you can right, come up with some measures using your tools, saying, okay, once we reach this bar, maybe we should be cautious about AI and how we interact with them.
Yeah. Yeah.
Right.
Yeah. No,
All right.
it's an exciting time. It's a lot.
Yes. Oh, thank you so much, and thanks all the
Sure.
audience. My friend from Luohan
Sorry,
Academy.
Professor Jackson. I have a question. Like, thank you so much for this interesting talk. Like we always think about AI as a thing that absorb like a sponge, like all the information from all around the world. But it's like a really interesting perspective to see it actually having its own kind of like personality and kind of like perspective in different situations. And it's also like really interesting to use AI to see like how different like human characteristic actually map to specific strategic scenarios. And like one thing I can think about like using it is like, for example, like now we use AI to make a lot of decisions, for example, in medical field to make decision like um, to whom should we like donate an important organ, and that kind of decision really um, matters to like patients and have like significant influence. So like it's, I think I'm not really sure whether it's like related to your research, but it's like it would be really interesting if we like actually prompt engineer like AI in some way to make it to have some perspective or have some personality that helps to make decisions in specific scenarios. And I think it's also like really important to understand how these scenarios relates with the games that you just talked about, so we can like better relates like different use like what we know to predict what we don't know.
Yes. Yeah. And I think, you know, part of it gets back to this question of training data too. As you're saying, we're training it on huge amounts of data. Maybe we train it on too much data. It's not that having more data is necessarily better in terms of getting AI to behave better. So it could be that, you know, by being more selective in how we train it, it behaves more reliably, or it behaves like, you know, it makes a better choices on organ, like who to give an organ to or something like that. So, you know, we have, that's a test that could be done, right? You know, you've got a problem, you've got organ donation, here's the situations, who do you give it to? How would a set of doctors make an expert choice on this? What would AI do? How much training data do we need to give it? Is it too generous? Is it not generous enough? Does it make, maybe it makes better decisions than the doctors? So there's lots of interesting questions. And I think, you know, this is sort of saying, yeah, let's put it in these situations, see how it behaves, and then try and understand what we think its motivations are, and then how we could begin to train it better, or design it better to do these tasks. So
Yeah. Now I know that AI has already like getting training data sets of specific like academic areas that like help it to gain domain knowledge. But it's like really interesting to think about it actually has like we have a training data sets that like map to a specific decision scenario or like personality or characteristic that will be really helpful like to have such kind of data set. And I know that like now data is like the most important thing for like developing AI, and your research like of like finding those words and like mapping to different scenarios is really valuable in that sense. Yeah, thank you so much for the interesting talk.
yeah, my pleasure. Thank you.
Thanks so much, Matt. Yeah.
Oh, sorry. I'm sorry for keeping you up
Maybe one
late.
last question. My friend from Luohan Academy has started to worry about time, but yeah, please.
Oh, I'm very sorry for keeping you up so late,
No,
Professor.
No.
So I'm actually doing some game theory research myself. So I'm just wondering, so I'm really inspired by your paper, and I think AI tools now can actually help us to have some new directions in game theory research. So I just want to ask you what is your stance on this? Why how we can use AI tools to do some new type of game theory research?
Yeah, I think, for games, there's a lot of games that it's very difficult to analyze. We can only analyze small games and we can solve them in certain situations. Once we get AI and we have some idea of why it's behaving, how it's behaving, we can build much larger systems. So we could test it on very large games and in new situations that we haven't tested before. So, the possible uses for it once we've got this, so we can use the LLMs as players in games. We can test very new and innovative games that are very difficult to solve. So it could be a very powerful tool in game theory, I think. And understanding parts of game theory that we didn't understand before, understanding, how different motivations translate into outcomes. So
Yeah, that's so cool. Yeah.
yeah, I think,
Yeah.
in terms of behavioral economics, we do know that people seem to behave differently from purely rational,
Yeah.
maximizing. But it's very difficult to have a systematic way of understanding that. And I think LLMs will give us a way of seeing how they, certain ones can behave, and then understanding how that translates into a lot of different strategic situations.
Yes, I think definitely. It seems like this gives us a tool to fine-tune, for instance, our fairness, how care for public good, for instance, may drive actions to which direction. So I think, yes, your research are really interesting. So I'm looking forward to more talks from you and reading more of your papers. Thank you so much. Sorry for keeping you up late.
No problem. Thank you.
Thank you.
Excellent.
Okay, thanks again, Matt. Yuan from Luohan Academy. Do you like to end this? Conclude?
I think
Yes.
Matthew is a really great talk, and we have very good discussions. And thank you for all the participants. We can see there are still more than 60 people still online. And hope you have enjoyed this talk. And you can follow up with our WeChat account or our email newsletter email, so you can attend a series of AI seminars. I think next week or next week. Okay. Thank you.
Yeah. Thanks
so much.
Thanks. It was a great pleasure.
Thanks again.
Thank you very much.
Thank you. Bye-bye.
Bye-bye.
Bye.